Hello and welcome back. Today we're going to use STL to create a window for our program, but before we get to that, I just want to quickly touch on the Mac side here. Some of you might be seeing this linker error where the linker doesn't actually know where to find STL2.framework even though we've installed it. And that might happen. It depends on sort of how your system is set up. And you know, even if we looked at STL2, we downloaded it, we saw the README and it said to copy the STL2 to this path, that's how you sort of install it. So we'll definitely need that to run our software. It's similar to like, you know, moving your .dll to the same folder that the executable is in. But the linker itself might not know where to look. So we can tell it where to look, and we can tell it to look here, or we could even tell it to look elsewhere. Like maybe we have the STL2 framework packaged within our directory here, and we just include it as part of our project. And that might be feasible as well, and that might be totally valid. So I just want to show how to do that real quick before we sort of move on to everything else. So if we just look at our premake5.lua here, we have these external dependencies, and we use this to sort of define like where our include or lib folders are. And this works pretty well on Windows because we can just tell it sort of where these folders are. And for example, the libdirs, further below here, we can just have the sysinclude dirs or the libdirs, and we can just give the libdirs sort of side by side here and then links. Unfortunately, libdirs doesn't quite work on Mac or Linux as far as I could tell anyway, so we have to manually tell it how to find the lib folders, and that's usually just done through like a -f or a -l in the linking step, sort of via the command line. And I don't want to have to update that every single time we add a new library. It's just for Mac and Linux. So what I'm going to do instead is have one folder that holds all of the libraries that we might have in package here for Mac and Linux respectively, and then we only have to update that linker line once. So here I'm just going to go ahead and add an externals, and I'll call it maclibs, and wherever we want to place it, so let's just put it in external/maclibs. Now that we've defined where we want our maclibs, we should just drop our STL2 framework in there. So we set external, and we'll create a new folder. How do you create a folder from here? Okay, let's maybe... there we go. Okay, so that's, you just have to do it from this view. So within the external folder, we'll add a new folder. We'll call it maclibs. And within maclibs, we'll just drop this STL2 framework in here. And that's all we need to do. Now we just need to actually link to it and sort of tell it where this maclibs is. So we've defined the external set maclibs. So down here, just under the, not Windows side, the Mac side, we can say links to STL2.framework, and that's still fine. And as you can see, sort of, I've set up my environment now so that it doesn't know where that is. And all I have to do is tell it where it is. So it needs absolute paths. So Lua or in Premake does support this. So I just usually create a variable to hold that. So abs path equals path.get absolute. And you can pass in the value that you care about. And obviously for us, it's externals.maclibs. Cool. And then the way you tell it is with link options. And again, it's a table. You can just add options sort of side by side. For us, we're going to add the -f option with a space after it. And then we're going to concatenate abs path. And the double dot there is how you concatenate strings in Lua. So -f space and then the absolute path to our externals.maclibs. And that should be all we need. So I'm just going to save this, and we should be able to just run this again. And you can see that this time it actually works. It knows where that STL2.framework is, and it links successfully. So if you were having that problem after the last video, you'll just need to do this to get it set up. Alternatively, you could also just type in the path where you install it here, library, /library/frameworks. But this way, it's actually, we're a little bit more in control, and we don't have to force anybody that wants to pull this code and run it to install this properly themselves. So we can do it this way. We could additionally have a post-build step that, again, sort of like we talked about with the DLL on the Windows side. We can have a step that takes all the maclibs from here and copies them to the user's library frameworks folder. That way you know you have access and permissions to modify that folder, and you don't, again, have to have the user that's trying to execute this code actually install anything on their system. And one more piece that I wanted to sort of touch on, and I'd like to thank Taras too for this, is I only know of system pause from years ago when I first started to learn to program C++. Apparently cin.ignore does the same thing, and it's cross-platform. So thank you to Ras2 for that. I will just update that here. So instead of the if-def for the Windows platform and system pause, we can just do we'll have to do a std cout to sort of still be able to say press enter to continue, and then we can do a std cin.ignore. And my Visual Assist is loading on the corners. I need to restart Windows for that. .ignore, and that should basically have the exact same effect, but it is cross-platform. So if we just rerun that, we should have no difference. You can see, and I can type whatever I want, but if I hit enter, it does. So that's perfect. Thank you again to Ras2. Now we can get to the fun stuff, and I think really to help us understand what that fun stuff is and how we're going to build this whole Hippo engine is really to just talk about our architecture a little bit. So right now we have two projects, right? We have Hippo and we have the editor, and they're two separate projects. Hippo comes out into a .lib and then gets linked into the editor. So we already have this sort of layer of sort of abstraction with all the engine code being up here and all of the editor code being down here. And again, editor just happens to be the app we're building, and it's going to use Hippo. Eventually we could have something like a player, maybe that just plays like our games, and again it would be linked to Hippo. Or additionally we could have even our own like just C++, generic C++ app that links to Hippo and does whatever we want it to do. So what we really want to focus on is really that Hippo box and sort of what's within it, right? And if we really think about what we want in there is, I really want the editor that sort of sits down here as a standalone app that links to Hippo to have a decent API between the two, right? I don't want the fact that you're sort of using hippo.lib to mean that you need to hold Windows state or anything like that, right? Hippo should encapsulate all of that for you. And what that really means is that Hippo will become, we'll have this class, we'll probably call it an engine, and this will be a singleton, and that's perfectly fine. Singletons get a lot of hate, they get overused in many different cases, but in this case it's perfectly justified because it's our single sort of point of contact between the editor or the player or whatever that is, the app, and the engine itself and the internals of the engine, right? Again, the fact that the engine is using SDL2 and it will have an SDL underscore window, like the app doesn't care, it shouldn't care. The engine handles that. The engine can sort of expose an API that says resize my window, and it will call the internal SDL functions to do so. Right? The whole point is that the engine handles this stuff for you. So our engine being a singleton, that is our single point of contact between the app itself and the engine itself, this will actually allow us to do sort of more interesting things as well. For example, subsystem management, right? Like you might have an asset subsystem for textures. So texture, and subsystems, I call them managers usually. So like texture manager. This might very well be a subsystem within the Hippo engine. We might also have an audio manager, and what else is there? Fonts maybe. We might have models or shaders. All of these different sort of assets, they might all have their own manager that sort of exposes them, right? So maybe the texture manager, when you say, hey texture manager, please load this file, we give it a path, .ping, and it converts it to an SDL, or in our case we're not using the SDL renderer, we'll use OpenGL. So we'll have an OpenGL like texture ID, right? And every time I ask for this .ping, I'll just get out a texture ID. The texture manager can focus on sort of taking this image, loading it into memory, loading it into OpenGL, and generating a texture ID from it, and then exposing it to the rest of the engine, right? And these subsystems themselves are all sort of part of engine, right? Another approach is that these subsystems are all their own singletons, and that's where it gets really messy, because the point of a singleton is that you have sort of your interfaces, it exists somewhere. Let's say this is the engine singleton, right? It'll be called engine. It has an instance method that returns that instance. or creates it if it's the first time you've called it. And I might say like do some work, call engine : get instance, and then do some other work. This, if it happens to be the first line, the first time I ever asked for that instance, it will actually instantiate the instance, and whatever other work comes with instantiating engine for the first time, right? So this is sort of one of the downfalls of singleton pattern, and usually you compensate for that with a factory or something else, and there's plenty of resources online that can tell you about alternatives to singletons. But the point here really is that for us, we know we want these managers that do this sort of concrete amount of work for us, and sort of we want to be able to interface with these managers and say, hey, get me this ping, and it will give me an ID. All of that can be done through the engine. We can have the engine define the load and shutdown order of these subsystems. And that's very important because, for example, the texture manager obviously needs OpenGL to exist, right? So the engine will need to make sure OpenGL is instantiated before it even tries to sort of initialize the texture manager. And if we were to push that onto the editor might not know that we need to initialize OpenGL first. It just says, hey, I just want to use some texture, so it'll initialize texture manager, and then it won't work. So having this level of control in terms of not just the subsystems that we expose, but also the order in which we initialize them and shut them down is very important. And this single point of contact allows us to do just that. When we initialize the engine, it will initialize the subsystems in the order it sees fit. And probably at the very beginning, you'll have a log manager, right, to log everything. And that is usually the very first subsystem you load, because you want to get logs for any of the subsystems that you're attempting to load in case they fail. And now for something that's actually a little more relevant to today's episode, it's this window stuff, right? So who owns this STL window pointer? Well, it definitely shouldn't be the editor, right? I don't want the editor. The editor should not care. So the engine will hold it. The engine will have n STL _ window, and it will expose, sort of an API to the editor, maybe like a resize window or a get window size or whatever it is. The engine will actually obfuscate that. Now, when it comes to Windows, the operating system does a lot more with a window than just, output graphics to it. It also, the window is the source of input for the software, right? So I might have a window with an X, whatever, little title, and the user might actually move their mouse right here, click and drag, and they expect it to get larger, right? This is what's called an operating system event, and basically the operating system saying, hey, the user wants to stretch this thing out. Are you going to do it? Sort of thing. And it's on us to handle that event. Now, SDL handles a lot of these base OS events for us, as I've mentioned in the past. So we just need to make sure that we pull those events so that Windows can tell SDL, and I'm saying Windows, in this case I'm referring to my operating system, it can tell SDL that the user wants to stretch the window out, and then SDL will handle that for us. And all we really care about is the stuff inside. We can draw things out there, we can get mouse input, we can get keyboard input when this is in focus, all those sorts of things. So let's go ahead and actually build that. The first thing we're going to do is go into our Hippo project, and we know we have these initialized shutdowns, but it's just random functions in a namespace. I don't want that anymore, right? So I want an actual class, we'll call it engine. And our engine will have some public and private methods. Now, of course, it's a singleton, so we know what that means. That means it has a private constructor. This ensures that nobody can create an engine. You have to access a static method to do so. So we'll have our engine as a private method, and we'll have a static engine star m instance. And then publicly, we'll expose a static engine reference instance. And I do reference because if I can avoid passing a raw pointer around, I'd rather do that. I'd rather pass in a reference, return a reference here. Mainly because, a raw pointer can be deleted by anybody, and we really should try to avoid those sorts of things. And of course, I could have this be a stud unique, and it owns its own stud unique, but we really don't need it. We're gonna maintain this one thing here once it's singleton, and we're gonna return a reference to it. We can also have our engine destructor, which currently won't do anything. We'll probably have it do something eventually. It'll probably call it shutdown method or something. But then we can just move these two in here. Actually, we'll move the three in here. So we'll have the initialize the shutdown, and maybe the get info will be a private method, and we'll just call it once at the beginning, sort of to like, as you initialize the engine, it gives you all the info. So I think this layout is good. Let's switch over to CPP. And now I like to usually do private, just to sort of have all my public stuff at the top and all my private stuff below. So we're already initializing, so this is good, and these are public, so I'll move them up top. So we're already initializing SDL, and that's great. I think we just need to sort of do something here that's a little more interesting than just print out the version. But the first thing we're going to want to do here is just make sure that we do that singleton piece. So singleton, we're going to define that engine star, right? Because it's a static member variable, so you have to define it as something to initialize it. So it's engine m instance equals null pointer, and then in the constructor, maybe the constructor will just call get info, right? It's the first thing it does. The very first time you sort of get access to this engine, it's going to print out the get info. And then in our sort of static getter method, and that's really up here, it's public, engine reference get instance, and actually maybe, did I call it instance? Yeah, I call it instance. Instance. As a singleton, you know, if you've done this before, you know what this looks like. You basically just check against that m instance. If it's null pointer, that means you know it's the first time you initialize it, so you create it on the heap, and if not, you just return it. So if not m instance, we can just say m instance equals new engine. This is what I'll call a constructor. This is what I'll actually call this getInfo call method. And then now you know that regardless of whether we went through this code path or not, we know m instance is valid. So we can return a reference to m instance, just like this. So now in main.cpp, instead of trying to do this sort of thing, maybe I think it's time to get rid of this hello YouTube, since we're going to get more engine output happening. We'll keep that at the below. And now what I want to do is just sort of get access to that engine and call initialize on it, right? So again, engine will return a reference to it, so I can actually capture that reference and keep one myself. So I can have hippo engine reference engine equals engine, actually hippo engine get instance, and then I can say engine.initialize engine.shutdown, just like I was doing before. So really this shouldn't change anything. We should have the exact same output, but actually not the YouTube print. But the key is that we have this engine singleton that we can now access. And if we run this, yep, whoops. So it's complaining that it can't find the implementation of engine : initialize, and it's correct. We haven't done that. So these are now member methods, and same with getInfo. And you can see we have the exact same output. And again, that's expected. But now we know that our singleton is working, and we can move on to actually creating some sort of abstraction to a window. So to create a window, usually what I do is I'll just sort of create another folder here, and I'll just call it, like, a window is an absolute core concept, right? Every app needs a window, like, you know, for our purposes anyways, you know, we're not just referring to the command line. So I just put it in this core folder. I don't really know what else is going to go in here, but I'll just call it core and put it in there. So I'll Control-Shift-A to create a new file. This will be window.h and window.cpp. And because I'm working in Visual Studio, I can just add files here, no problem. It will add them both to the directory and to the solution. Next time I gen-SLN, it will regenerate the solution, but it will still work. Now I want to define what this sort of window class looks like. So, and I usually have my namespaces match my folder structures, so I usually do that. And class window. Now what does a window have? A window really just has the SDL version of a window for now. We're going to probably add to this. And I'm going to forward declare here what the SDL window is, which is a struct SDL_window. And I forward declare it, SDL gives me a pointer to an SDL window, so I'll keep it in as pointer. So SDL window star and window. And this will be the actual window to handle to the SDL thing. Window will have a constructor and a destructor. And we'll have, we'll be able to call a method on a window. So the engine will have a window, and at some point, somebody will call create on it, and again shut down. So we'll do a bool create, and we'll just do this, and then void shutdown. You can imagine that these will sort of correlate to our engine initialize and shutdown methods. And that's another good part of having a singleton, is that we can have it control the order of how we sort of initialize and shut down these subsystems and these managers. For now, this is all we need. So let's switch over to the CPP. We'll include window.h, and actually core window.h. And here we're actually going to include our SDL2/SDL.h. I think we had to make it capitalized because of Mac. Namespace hippo core. And now we can define these methods. So in the constructor, all we're going to do is have that mwindow be null pointer to make sure that we initialize it properly. In the Windows destructor, oops. I usually like to check against like mwindow. If mwindow is valid, then I know I need to shut down the window. Otherwise, it won't do anything. And that way, if something fails in the initialization step and we don't set that, when we destruct this, we don't have to run any code. Now we'll create the window. And again, it's just a simple call. mwindow equals SDL_create window. Now take some parameters. I'll just put some defaults in for now. So the title, we'll call it hippo game. The X and the Y, so this is the position on the screen, on the main screen, where you want the window, the top left of the window to load. So we can do 0, 0, and it'll be at the very top left. SDL also provides some sort of magic numbers for us that means something and that will force SDL to do something different. So for example, SDL_window_pos_centered will make sure that the X is centered. Depending on the width and the height of the screen, it'll make sure that the entire window is actually centered on the screen. So we'll pass that in for both X and Y. And then width and height, we'll just initialize to, I don't know, 800 by 600. And then take some flags. We don't actually need any flags, so we can just pass in 0 for now. And now we just check if the window is created properly. So like what we do here, if it's not created properly, oops, we'll just print error creating window, STL get error again, instead endl, and I'll have to include IO stream for this. And then I can just return false from here. Otherwise, I'll just return true. Right? There's nothing else we need to do. Again, we're just abstracting out the SDL call here. Similar to SDL shutting down, we need to shut down and clean up windows as well. So window shut down. We will just call this method SDL destroy window and pass in the pointer to the window, and then just reset that pointer to null pointer to make sure that it's cleaned up. And that should be all we need. So window should work, we just need to have a window now. So let's go back to our engine. And I'll have to include that window, so core/window. And this is why I forward declared SDL window in the header, because if I include window from this header, and then include this header from engine.header, our main.cpp includes engine. And it will eventually need to know about SDL. And I think I mean, it's not really a big deal if it does know about it and has to include it, but I think I want to try to avoid it just for now, in case, if I can easily, I'll just avoid it for now. So again, I'll just include window, and now I can have a window myself. So now I have a window, and in the CPP, we just hook it into the flow. So again, shutdown, for example. Before we quit SDL, we should shut down our window. So window.shutdown. And then when we initialize SDL, if we were able to initialize everything properly, then I can keep printing the version, but I will also now want to create a window. So I do have this red equals false thing. So if I cannot mwindow.create red equals false. And I don't need a print here because this will print itself if it fails. So I really just want to make sure I can create the window, and if I can't, I'll just make sure I return false to the caller. Now, initialize isn't actually getting checked by anything, so it's just gonna do stuff anyways. We can actually force the caller to handle it, because we definitely don't want the caller to do anything if initializing hippo failed. So what I can do is in the header, I can actually add this tag, no discard. And the way you do it is like this. You have these two square brackets. Oh, I don't know why IntelliSense thought that was wrong. You have these two square brackets, you write no discard. And basically what it'll do is it'll throw a warning if somebody is calling initialize without actually capturing the return variable. So that it's going to force me, and I can actually show this, so if I just try to run it. And because we've said all warnings are errors, you'll see the following warnings. Here's an error. Discarding return value of function with no discard attribute. So that's exactly what we want. We want to say if engine, and this works, then we can start doing stuff. Else, you know, we'll just move on to the shutdown. Basically, for now, it doesn't really make much sense, but this is really just to protect the engine itself and make sure that the caller can't, well, we're not preventing them from calling other methods on the engine if this fails, but we're at least trying to tell them that that is the intention here. So if I run this now, you didn't see it, but a window flashed and then immediately died because we're going directly to shutdown. So we need to actually do something in here. For now, let's just while true. Let's just sit here and do absolutely nothing. And there we go. We have a window that says Hippo Game and is 800 by 600 pixels centered on the screen. Now my cursor is idling and I can't actually do anything with this window. And this is what I was talking about earlier. We have to handle those operating system events. What's basically happening here is all of the events are stored in a queue. So there's going to be a queue, and like, I don't know, I'm going to move my mouse a little bit. So there's going to be an event, you know, like a mouse move event. Then I'm going to click and drag on the window to try and resize it. So there will be a resize event. Then there might be like a refresh draw, like so refresh like the panel. Refresh. And then maybe I click the X button, right? So then there's going to be a close or a quit event. All of these events are getting queued by the OS, and the app needs to be able to parse, sort of go through these in the order that they were received. What's happening right now is we're sitting in a while loop that does nothing. So these are just staying in that queue and we're not doing anything with them. So STL does give us a way to actually parse through these events. We can actually see what all of these events are and do something accordingly. And as we handle them, they get popped off, right? So now we're here, and then we handle the first one, then we handle the second one, then we handle the third one, and so on. And we keep doing that in a loop until we've handled all of them and there's nothing else. And then on the next frame, any of the operating system events that have accumulated over that course of that frame will be in that queue. And then we'll loop through them again at that point in time and handle them as well. So in order to do that, we're going to go back to our window. And I said the window handles this because it is absolutely part of the window. We're going to have an additional method here that sort of is called pump events. And this is sort of going to do exactly what I just said it did. It's going to pump the events from the operating system. So in here, again, the way STL lets us pump events is by storing them in this arbitrary object. So STL event E is just a struct that has pretty much everything you need to capture any data for any OS event ever. And then we'll make this call in a loop to STL_poll event. I'll pass in a reference to E. So every time we call this function, it's going to get the next thing in that queue. And it's going to populate this STL_event object with that data. So now we can act on that data. Now we don't really need to do anything right now, so let's just leave it here. But instead of having that while true loop do nothing, we'll have that while true loop call this pump events, which will iterate over all of those events. So this is now basically, this has become our game loop. Now as I'm writing this, I'm thinking about sort of, we're calling initialize on the engine. We are now defining a game loop where we as the client have to tell the engine to pump the OS events. That really doesn't sit right with me, right? Like that's very much an engine specific thing. Like our client shouldn't have to tell the engine to do something so fundamental to having a window in the first place. So I'm gonna actually switch things up a little bit. I don't want our client to call initialize and shutdown at the right time, at the right place. I don't want to do any of that. I just want to tell the engine to run. Just do your thing. So if I replace all of this with engine.run, this method will have everything we need in terms of actually executing code, going through that game loop, calling out to systems, doing all the work we needed to do. So let's go over back here, and I actually don't want to expose these anymore, so we're going to move them down here so they're private, and I just want a void run method. Initialize and shutdown will continue to do sort of what they do, and they'll stay down here. They're just private now, and our run method will handle everything for us. So as soon as this run method returns, the game is over. It's done. The software closes. That's the point. We want everything to happen in here. This is going to hold the core loop. So again, we can call initialize from here, but we have to check the return value. So if initialize, then we can actually have our core loop here. While true, and window.pump events, right? Because this engine holds the window, it can just do that. And then when it's done, we'll call shutdown. Now, obviously, we're never going to get here without forescaling the software, but we'll come back and fix that up. I just want to see the events being pumped. Now, one of the things here is that shutdown will not actually be called if initialize fails. Like, let's say SEL init succeeds, but I can't create my window. I want to make sure I still close STL init with an STL quit, right? So maybe at the very bottom, before we, because we're just if else and sort of setting this ret. Down here, maybe if ret is false, we'll just we can even print engine initialization failed, shutting down, and then we can just call shutdown here. And basically shutdown, even if window is not valid, that's fine. Its shutdown will make sure that there's something there to shut down, and then it will make sure that we call STL quit. If STL init fails, it's still safe to call STL quit. So it's okay to have the sort of case where even if this fails, we still call shutdown, and everything will sort of shut itself down if necessary. So now that main is calling .run, and whenever run returns, we're done, we should be able to run this now. And you can see that it does work. My mouse is switched back now, and I can drag this window around. Can I resize it? I cannot resize it because I haven't told STL that I'm allowing the user to resize it. For example, things like, again, basic OS functions like minimize. That works, right? Maximize, or come back. I haven't told it it's, again, resizable or maximizable or full screen or anything like that, so it grades it out for me. And I have an X button that should close the software. Fortunately, it doesn't do anything. And you should probably know why. We don't handle events, we just pull them, right? We don't do anything with a quit event. So that's sort of the next step here. We should be able to determine whether the user has clicked that X button and do something with it. For now, we can just quit the engine entirely, but we might, as an editor, when you try to close it, if you have unsaved changes, we might want to say, hey, are you sure you want to close? And we can actually, just like we're ignoring it here, we can ignore it in those cases as well. So the way we check what event we have is by checking e.type. So we can switch on that. And in the case that it's STL underscore quit, we can tell the software to quit. So we'll break. I'll have a default break anyways, just to make sure that everything else is captured properly. Some compilers don't like sort of switch statements that don't have every case. Now we don't have a way to quit. We can't tell the engine to shut itself down. The engine is going to, in a while true loop, keep running. So let's add a concept of whether we're supposed to be running or not. We'll just have a bool. M is running. So now we have that. We need a way to actually set it. So we can have a void quit maybe, and we can actually make this inline. It's just going to reset that flag. So M is running equals false, right? So in our constructor now, we can make that also initialize to false. Is running false. And then we'll only set it to true sort of if ret is happy, right? Like if after initializing everything is good, we can then set it to true. It also almost makes me want to like change the default to false. Let's pretend we're not going to succeed. And if it was wrong, we'll do that. Else, we'll do this. And if we can't create, it was bad, and it will print. But now we can just sort of change this to true. As we sort of nest more if checks for initialization steps, we can just have it all set to false and only set it to true at the very end when we know everything has been initialized correctly. And so in here we can also set M is running equals true. right? Once we know everything's good, we know we can start running this. So if initialize, we'll not just say if m is running. And now the window can actually call that method back on the engine and tell it to quit. And the way we do that is, again, because engine is a singleton we can access from anywhere, our window would just need to know what that is. So let's include, and I usually have some sort of structure to my includes, engine.h. And when we get the quit event, we can just call hippo. Actually, we're in hippo namespace, so we just engine instance dot quit. And so again, the point isn't that this quits immediately. There's nothing wrong with having one last frame go through before we end up quitting. The point is to tell the engine that we want to quit. The intent is to quit, and it will not quit until the next loop, right? And then it'll call its shutdown. But that's good enough for us. So let's give that a shot. So you can see I have my window here, and I can do everything. And if I click X, it shuts itself down, and this is back to main. So this is at the point where the engine.run has returned, and we're now here. So that's exactly what we want. And maybe just one more thing. I think I want to make sure that, yeah, here we set it to true in the initialize. We should actually reset it to false in the shutdown, just to be clean about it. I don't want any bugs where that's not been reset properly. And that's it for today. We have a window working. Thanks for watching.